Welcome everyone on the occasion of 1 week webinar on integrated approach in science and technology for a sustainable future. Tonight our resource person will be Dr. Rebecca Lalngaihawmai, Assistant Professor, Department of Physics, Government Circuit College. She will present our tonight's program on the topic of physics for a sustainable development. Before we proceed, I'd like to remind my fellow colleague not to forget to put your name, roll number, and semester on the chat box. Make sure that you enroll it, as it will be taken as attendance. Now let's hand over our time to our resource person, Dr. Rebecca Lalngaihawmai, to take over her time. Miss, time is yours.
Thank you very much, Lalngaihawmai, for your invitation. So tonight I will be talking on the physics for sustainable development. So first, I will share my screen, and after that, I will proceed to my presentation. But please bear with me before I share my screen. I hope it is visible. Ramhak, is it visible?
Yes, Miss.
Okay, let's get on to our topic. So this year, sorry, my voice is not clear. So on this occasion of National Science Day, it is all about the sustainable development, sustainable future, and its application. So I want to choose some topic about the sustainable development and in relation with physics subject. So here, first, let us try to understand what is the meaning of sustainability. Okay, so it is according to the UN World Commission of Development and Environment. It is the meeting of the needs of the present without compromising the ability of the future generation to meet their own needs. Here, it means that we are trying to make use of the present without destroying or without compromising the future generation. So we are trying to use the present resources for the future generation. So these are the three components of sustainable development according to the UN. So first, the UN are trying to develop the social, economic, as well as the environmental responsibility in different ways, which are given in this chart. So here, the main theme of environmental sustainability or sustainable development is to reduce, reuse, and recycle what we have already have before. So I will not get into much detail with this thing because I'm trying to explain much into detail about the sustainable goals. So these are the sustainable goals. The different sustainable goals as given by the UN. So to eliminate poverty, zero hunger, and all these things. So physics has much thing to do with all these sustainable goals. So let's get on to the next slide. So as we already know that physics plays a very important role, ranging from the energy, low energy, to high energy technology. Okay, so here utilizing the solar and wind power that are renewable resources, so we can utilize these resources for sustainable development in the coming future generations. So as you can see from this diagram, so here we have the solar power from which we can obtain different energy sources. So this is this solar power. It is free of cost, so we can use it like in many technological applications, even at home and industry and so on. So at home, this solar technology can be used even in solar oven, solar cooking, water heating system, and even for electricity as well. So in order to so in order to provide electricity, we can use it in different reservoir as well as in irrigation system as well. And moreover, we can use it for biogas and generator, and even wind energy can be used for generating electricity using wind turbine. So I hope you have already come across this thing even in your lower classes, high school and higher secondary level as well. So this is how solar energy and wind power are all related with this thing. So even in Mizoram, we have ZEDA, that is Mizoram Electrical Development Agency. So they are using this solar plates to capture all the solar energy from the sun and thereby using it to generate electricity, which are being utilized by many villages in the rural as well as in the urban areas. So this is how it works. So from sunlight, we get the energy, which is in the form of photovoltaic energy, and not only this photovoltaic energy. So this sunlight gives us its warmth. So this can be utilized for solar thermal, which can be used for generation of electricity that I have already mentioned before, as well as in the production of heat. So this can be utilized in any region in which we are located, even in the remote areas of the country or the state. So these are they provide low cost of electricity, as well as for the generation of electricity we do not need much cost. That is the benefit of this solar energy as well as wind power. Okay, so like we can invest solar energy and other renewable resources, which are very good to protect the environment in the near future as well. So another uses of solar energy is that another benefit, as we may say, of solar energy is that it lowers the emission of greenhouse gases without affecting the growth of the country or technology as well. So since we know that since solar power is 100% renewable, so if you say it is renewable, it can be used over and over again. Oh, as I tell this one next is that it is an alternative source in lieu of the fossil fuel, as well as another to fossil fuel, as well as another source of energy. And moreover, it does not produce much pollution, so it is a very environmental friendly. And next is that when we use this solar energy to generate electricity to produce power, so we can save a number of tons of we can produce 1.2 tons of carbon dioxide. We can save this 1.2 tons of carbon dioxide. So these are some benefits of the solar energy in our daily life. So from this diagram, as I hope we can see, these are the different forms of energy. So from this form of energy, we have like nuclear energy, sound energy, light energy. So the main source of energy is light here. So we can convert it into various forms of energy like thermal energy, electrical energy. So even we can store this energy in the form of chemical as well as potential, further classified into this thing, gravitational as well. So I will not go much into detail with this one. So even in the nuclear energy is also one form of energy. So here there will be fusion, splitting of energy, as well as emission of energy as well in this nuclear energy. So this energy coming from the light, which is very hot, can be converted into thermal energy, which are further used for conduction, convection, as well as radiation. And as we can see from here, when the energy is released, so it comes in the form of electrical energy or another form of energy. So all this energy are interrelated with one another. So this diagram shows the uses of different forms of energy, different form of energy like coal, solar, natural gas, which will be concentrated in one system and will be distributed to different levels of which will be distributed to different forms like in the commercial, industrial, residential, as well as in the far-flung areas as well. So next I will be talking about the accelerator mass spectroscopy. So this accelerator mass spectroscopy is a very important tool for environmental measurement. I hope you have already come across the carbon dating. So these are very much used in the archaeological surveyor as well as to detect or to analyze fossils and the remnants of dead bodies or nghe kan sayang miso chungchuan thilrei to de to ka chungchuan ante entikuma lo to nge ti ka chungchuan tang khalang nakshi. All right. So even it is used for understanding the oceanic circulation, which has very much to do with the climatic changes. And moreover, it is also used in biomedical resources and ocean resources as well. So accelerator mass spectroscopy for here, carbon dating. So most of the time, this carbon-14 is used for determining the archaeological artifacts as well as geological samples. So this below here we have the accelerator mass spectrometer. So here is the working and construction. These are the working and construction and how this accelerator mass spectroscopy works. But I will not go much into detail because vài cái sự chạm thấy đuôn lâu cho bạn physics student rất cần nhiều bằng khan không to detailing by constructor level. So next is that this accelerator mass spectroscopy. In short form, we can say AMS. So it helps in locating carbon-emitted areas for improving the accuracy of measurement. And the until we do to tin more, more till we meet an archaeologist can till we can observe that say so an kang atang carbon dating atang kan hemi here in here instrument kan tin yang chu kami ka an ka hanga chuan entikuma lo omnge tiang te ka an chom chuan so some of the few isotopes of this AMS includes this in the adeva in lawatana and atan katuan a carbon dating atan katuan carbon 14 the beryllium 10 katian takan hawi and mantlang with next we'll move on to the superconductivity. I hope you've already come across this superconductivity. And the result kan soile lo nga metals there ahian conductor te insulator te kataha kan ya amero to superconductivity conductor to any electric current kaltlam thein ang khaleta those thing in which electric can easily pass through conductor nita amero to superconductivity avetung ai chuan temperature yam to ka khan he khathil ha metal ka andata to when they are cooled to a very low temperature below a certain critical temperature. It has a certain critical temperature can share to 0 Kelvin. Okay, what is the difference between Kelvin and Celsius? What 0 degrees Celsius to 273 Kelvin I into amero to 0 Kelvin 0 degrees Celsius in the Kelvin here 273 Kelvin and the I took me to amero to him is superconductivity to 0 Kelvin over 9. So tonight one and here research ka tazela it's one high temperature superconductivity the poka amero to me I can share to high temperature superconductivity at 0 degrees Celsius poka han hello amero to 0 Kelvin is what we am told to ka hemi aya samti a poka high high temperature superconductivity poka to lie at one scientists can mutual at all amero to me to zain at one can story lawanga it's one in a superconductivity here at what is the benefit of superconductivity can teach one so it can zero electrical resistance in a book and a culture to attract to conductor at one in the electrical resistance ka change in number temperature akan amero to hemi big hits one superconductivity big hits one electrical resistance ka a free angni poi muna ko kana kalthai anga chu a benefit to lo wita it's one how we a properties how can it mase I would that one can explain how we can explain to lo it's one hit here in ula from this diagram, as you can see that this diagram shows the non-superconductive metal, whereas below here we have the superconducting material. So at a certain temperature, it is at 0 degree Kelvin. So this metal will have a superconductor. So this is very beneficial for the sustainable development in our future. So this superconductor is classified into two types. One, the first one is known as the type 1 superconductor, which is also known as a soft superconductor, and type 2 is known as the hard superconductor. So in here, soft superconductor type 1 and type 2 in the difference between the two is that in the soft superconductor in temperature in a muakan and superconductor in a hlau ma ani to one hemi big one at certain temperature, this superconductor may lose its superconductivity, whereas in type 2 type 2 or hard superconductor, they do not usually they lose their superconductivity. So this is uh, better than that, or the type 2 is better than that of the type 1 superconductor. All right, so few examples of soft superconductors are like lead, mercury, aluminum, etc. Sorry, aluminum is in the hard superconductor. So this diagram shows the difference between the type 1 as well as type 2 superconductor. Here is superconductor chikhat khala unita. This one here this one is already constructed in Japan. Hey, Japan in the diagram karon la kahe. So in the what happens to these superconductors inside? Here we have different section. Here we have liquid nitrogen, which is the inlet. We have dielectric material. Here we have the liquid nitrogen as well as the cable crystal. So atung hai cable chung ai he hau song song hi oma. So he mi hau song song here superconductivity ka in the as in superconductivity at one low temperature ha am mo wang khan liquid nitrogen ka low temperature sam to tan khan apoi mo ta em tan. So this superconductivity was first observed by Dutch physicist H.K. Ons in the year 1911. It was only about around 100 years back. So what happens to this superconductivity is that so it has a zero resistance which occurs at very low temperature. So as we can see that that mercury is one of the superconductor. So this superconductor when mercury is at around 4.2 Kelvin. Okay, 4.2 Kelvin so at yang to kan degree Celsius 0 le 273 Kelvin and if it is like 4.2 Kelvin, the temperature will be very low here. So at this stage, mercury behaves as a superconductivity. So here, one thing to note about the superconducting material is that it should have a very high magnetic. It requires a very high magnetic field, which are used in MRI to ensure this magnetic resonance imaging contain here medical industry and harness superconductivity hi ta se MRI okay chuan in enge taksa ai luru te an engine ka taksa chung te en nan ten an hanga. So this is one very important application of superconductivity in our daily life. So in addition to this, there are many other uses and applications of superconductivity which are of technological application in our day-to-day life. So this, as we have already said that superconductivity, it has zero resistance. It can travel a very long distance. And obstruction kan travel kan so this superconductor materials, superconductivity le superconductor the device or the material which possesses superconductivity, they are known as superconductors. As we have said, mercury, lead, aluminum, superconducting material this superconducting material they include chemical elements such as mercury or lead. The alloys to engage one element pahni emo atathuma pahni aya tam chimshim in kopkhan alloys ka in siam theni. bronze te po ka alloys te khat ani amai ro chu bronze ka superconductivity and herting and lawa that is the meaning of alloys. So they are this superconducting material they include are ceramics kan ti te chuan superconducting nitrides kan ti te organic superconductors organic te chu he basiam chuk ni lo okay te ati ang omsa how ka superconductors te po ka om kang how ka ni ta so this superconductor they conserve an enormous amount of exhausted energy ka tam tam taka ka aveng him a conserve the bang khan he environmental friendly to bang chuan sustainable future tam pu khan kun like I've said, it can be transmitted to long distance due to its low resistance, as well as it requires a very low temperature. So this is the inside. This is some few diagrams of the superconductors. So inside here, a cable chunga dan kalamita. A device how kalamita. This is also another forms of superconductor.
I might thought of them.
At high pressure, and yellow shows the superconducting elements in modified form. So this heta hel in lang mu ka ringa helai borvel asen lai hi abal ka ho khan ta so helai he calcium tan la he ka high pressure ho khan ta so I will not go much into detail with this thing. So these are the different areas of superconducting application in science, medical, transportation industry, and in energy as well. So helai ahman chang kai na kanita accelerator kan ti te in India ma hian accelerator center hi New Delhi oma nikya engmo ta zirlai ho to higher studies in the kai chuan helai mun hi to ve ni la tum ro ke hi po college kan kala kan to apu ani amai ro chu enge du ak to thai ni lawa deal na te khap thelu pe nga ya chung te po chu aparo pu accelerator he mi India sarkar tan ya chu te ang chi to po chu ta chon hi NMR kan ti te non magnetic resonance anita chu chon MRI chu atlang lo nu tu ka MRI it is used for scanning atan kan hanga chuan red lan chak chi maklef kan ti ang chi high speed train kan ti ang chi ta pokha these are they are using this superconductivity for its technological applications. So likewise, even in motors, generator, transformer, cables, etc. And, in addition to this, there are many technological applications of superconductor in our daily life. So these are the winners of Nobel Prize in Physics in the recent years, as we may say, like from 1913. Superconductivity again Nobel Prize mo hi an tam to em ani chuwa chu superconductivity hi atun la ya a trending consultant to atun la a trending la chuwa chuan zirme research apo physics pe ka chuan a trending em ani hemi research hi chuwa chuan hemi Nobel Prize po hi tun mai anga te po anyang chu Nobel Prize okay, so I will not read out all these things. I hope you can see from this here that Many have won this prize in superconductivity, and ongoing research, many ongoing research are still there. So that is all about my talk for tonight. Thank you.
Thank you very much to our source person, Dr. Rebecca Lalngaihawmai, for presenting us a great and wonderful presentation. I hope and pray that our tonight's program would be a channel of blessing to each and every one of us. And before we end our program, I'd like to hand over this program to Sarjana for some announcement.
Sẽ thêm tu ni som ni pariat ni som thum ma hian MZU Biones te khan kan college sa hian innovative challenge khai dikina business contest kha omdo na chuta chuan in field na le thu ka han kam ke ma turan hun te kha miron siam sak te waron ti a principal la le khan hon kaltira chumi le kha chu bosi ngai nam thri lo tu na hian principal hi a home my soy na oma wena phone in the caller in nei time ki ta chuan nei gulan mai lo ma ti a hil thata ka ni a hi bio innovative challenge ha hian enge in idea ho kha a feasible engem a viable em ti ang chi ng zonga business plan contest nei tur khani ta ni chu a khu hon na te le ak ang tal dan tlang pui kha di som ni pare di som thuma he mini som panga mini som li panga le kunaron mang do na chu ta chuan a detail program le enge tu turang kha kan ron thil chunga ke na tura chun kan la in ready chelo wa MZU lampo kan rem ti e ti po acknowledgement ang ba willingness po kan la pe chung lo wa amaro chun nei tura ingai ta ila chu ta chuan abi takin bio lampang zoology le botany pe ka chu tuna bio innovative challenge sa hian tel ngi ula ka duwa tu la kain pui to nanga team DPR CMMO eng business pan eng poni se chuang chuan zanina lo eten zong te le in thian te po lo fil ula government ship college sa hian business contest le biones ina tuna bio innovative challenge hi organize ani don ani chu da chuan in business pan tel tu na hian idea lo som khom tan ula enge ka tiang enge idea nge kan te group ang te pon in the chain kha adi te la kha chu ni som ni pare ta mo ni som thuma mo MZU tang representative from kalte khan program organize dona ta chuan detailing kan thebek thenga khami tur khan lo in ready ro ti hi garon septel velok du ni lo me.
Thank you very much, Sarjana, for your informative announcement. Lastly, for the end of our program, on behalf of Mathematics Department, I'd like to thanks to our principal, our staffs, and my colleague for attending till the end of our program. Thank you very much. Good night all.